Okay, so this is lesson 18. And again, this is the third day of the chain rule. So as long as you've been keeping up to date, it really shouldn't be too terrible. When you're using the chain rule, and frankly, even when you're not using the chain rule, and these derivatives get more and more complicated, you just want to keep an eye on what I call the big picture. What is the biggest kind of derivative that you have to worry about? Is it a product rule? Is it a quotient rule? Is it a trig problem? Is it a power rule? So again, these are all the different things that you might be asked to use: the chain rule, the power rule, trig rules, product rules, and quotient rules. And again, your green sheet is always available to you, so please make sure you use it. We are at the point now where I do want you to factor and simplify your answers. Okay, so keep that in mind for the homework, keep that in mind for the quiz. And again, that's something that should be easier when you have two people to look out instead of just one. So take a look here at number 1. If I was going to try to describe the biggest rule that I have to use to take this derivative, does anybody know what I'm looking for you to say here? What kind of an operation is in this problem? There's a square root. What else though? A what? Well, there's an x squared, then there's a square root of 1 minus x squared. What are you being asked to do with those two things? You're being asked to multiply those, which means we probably need to use what? The product rule. So again, I say BP for big picture. This is a product rule problem at its core, and then you're most likely going to have to use the chain rule. Again, from this point forward for the rest of the year, not that you have to use the chain rule, but it's always an option. So I'm going to make sure that I'm using the product rule. And again, I'm going to use the chain rule when I see fit. So let's go back to the old days. Let's do FF prime, GG prime, since I think for some of us that was helpful. I left you lots of room, but still use it sparingly because there's quite a few steps. So first, let's do F. F is x squared. What's the derivative of x squared? 2x. Again, that's just a nice regular derivative, no chain rule required. Then your G, I'm going to rewrite the square root of 1 minus x squared as 1 minus x squared to the half. And just to be clear, you do not know the square root of 1 minus x squared. It's not 1 plus x. It's not 1 minus x. It is not something you know, so don't pretend that you do. Okay, if I'm now going to ask you to take G prime, you're going to bring down the half. You're going to take the whole thing to the 1 less power. And then you have to use the chain rule, which means multiply it times the derivative of the inside, which is what? What's the derivative of 1? 0. And the derivative of negative x squared? Negative 2x. So don't forget the negative. And while you're here, why don't you just clean that up? That 1/2 and that negative 2. We can, and let's just multiply those to clean it up a little bit. So if I go ahead and multiply those, I'm just going to get a negative x and then a 1 minus x squared to the negative 1/2. So before we go any further, just look at that and see if it makes sense. Can you identify the f and then take the derivative? Can you identify the g and then take the derivative? And then again, I just simplified it so I don't have to worry about doing it later. So any questions or issues on that? Yes. So you can't have negative answers. You can't have negative exponents in your answer, but it's okay to leave them here because you can get rid of them eventually. All right, because this problem is a y equals, we're either going to call it y prime or dy dx. At this point, it doesn't really matter. So if you want to go y prime, that's fine because there's a lot going on. If you remember the quotient rule by heart, great. If you don't, look at your green sheet. But the quotient rule says you're going to start with f, which is x squared, and you're going to multiply it times the derivative of g, which is negative x, times 1 minus x squared to the negative 1/2 power. So f times g prime. Then it's always, 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 always a plus. Then you're going to multiply it times g, which is 1 minus x squared to the 1/2, times the derivative of f, which is 2x. At that point, it really is just a matter of following the formula. F times g prime plus g times f prime. So any issues on that? Okay, let's go ahead and multiply this and this, just kind of try to clean them up a little bit. So y prime equals, I can multiply these two things together. So a negative x times an x squared is a negative x cubed. And then 1 minus x squared to the negative 1/2. Then I'm just going to put the 2x in the front so that it looks similar. At this step, you're all done with the calculus. All that's left is the algebra. So to finish, I want you to factor and simplify. So think back to lesson 13. We had a whole lesson on that messy factoring, and that's what this is again. If you're trying to save space, it's probably like 3 more steps. And again, I try to leave you a lot of room, but use a separate sheet if you need. So you're now going to try to factor out of each term. Remember, terms are separated by the pluses or minuses. So this separates the terms. So you're going to try to factor the GCF out of both. So first, look at just the regular x's. If this is a negative x cubed for the first one and a positive 2x for the second, how many x's could you take out? Just an x, or you could take out a negative x. It doesn't really matter, but I like to say when in doubt, take the negative out. And then you can clearly take out a copy of 1 minus x squared because they both have one. And then let's see if you remember back from lesson 13. If one of them is positive and one of them is negative, should you take out the positive or the negative? The negative. So you're going to take out negative 1/2 power. So that is your GCF. You're going to put it out front. Then you have to decide what are you left with from each term. So starting with the first term, if this is a negative x cubed and you took out a negative x, how many x's are you left with? Just x squared. If this is 1 minus x cubed to the negative 1/2 and you take out all of them, then there are none left. So all you're left with is an x squared. Is that okay? Okay, we're not there yet. We just did the first term. So now, yes, we have a positive 2x. So remember, we took out a negative x, so I have to be left with a minus and then a 2. And then remember my trick, if you're trying to figure out how many 1 minus x squared you're left with, you're going to do the original minus whatever you took out. So you're doing 1/2 minus negative 1/2. What happens if you minus a minus? It's a plus. What's a half times a half? 1. Remember, not the number 1, but 1 copy. And remember, spoiler alert, it's going to be 1 most of the time, because if it isn't, you can't go any further. So again, I know there's a lot of steps. I get it, but that's partly why it's only a few problems and partly why I'm going to give you a partner. So questions here. Yes. Why? So this here. Okay. So you're looking at this term right here. This is a positive 1/2 and you're taking out a negative 1/2. So if you're trying to figure out how many copies of 1 minus x squared you're left with, you have to do the original 1/2 minus negative 1/2, and that's how you get positive. Okay, so we're almost done now. Within here, let's just go ahead and distribute. So this is x squared minus 2 plus 2x squared. If you combine like terms, you get 3x squared minus 2. Yes. And then you just have to bring this to the party. So here I'm going to leave the negative x on the top, and then I'm going to move 1 minus x squared to the bottom and turn it into a positive 1/2. So that is ultimately my final answer. Nice and Christmassy for you. No, factored is better than multiplied. But again, there's only going to be, on this quiz, I'm only envisioning like 6-ish problems, give or take. So if you wanted to come up and say, should I factor this? Should I multiply it through? I will happily answer. Yes, Johnny? Oh, I had a hand. Same question, okay? Again, yes, we're at the point now where factored is better than not factored, which is why you would leave the negative x. So again, I'm not saying that it's easy, okay? But again, this is why there's only a handful of problems. So you just have to take your time, do it methodically, nice and simple, and hopefully it makes sense. So any questions on this one before we move on to the next one? And again, part of why I'm recording this is so that when you, if you need to go back later and rewatch it, you certainly can. Okay, so let's go ahead and take a look at number 2 then. And again, I tried to leave you a lot of space, but still make sure that you're using it wisely because there's quite a few steps. Okay, from here, if I was to ask you for the BP, which I mean big picture, what kind of rule am I going to have to use to take the derivative of this? The quotient rule. So I think as somebody said product, guys, it's divided, so it's a quotient. And then again, you may or may not need the chain rule. So again, good to just have an idea of the big picture here. Again, I certainly think we're at the point now where we still should be doing f prime, gg prime. So f is just regular x. What about the derivative of x? Is just 1. G is x squared plus 4 to the 1/3 power. Remember, that's equivalent to a cube root. And then the derivative of g, you'll bring down the 1/3. You'll take the entire quantity to the 1 less power, 1/3 minus 1, which is 1/3 minus 3/3, which is negative 2/3. Then you have to do the chain rule, derivative of the inside. What's the derivative of x squared plus 4? 2x. And again, if you just want to clean that up a touch, you can do 2x over 3, and then x squared plus 4 to the negative 2/3 power. So any questions how I got f prime, gg prime, or why this is a quotient? Remember, quotient means division, product means multiplication. Yes? So you'd have to make it to the negative 1/3. Yes. I don't do it that way because every time people try to do it that way, they forget the negative and they make mistakes. So I think it's better to do it as a quotient rule. But if you do it as a product rule correctly, yes, that would be fine. Yes. Okay, so again, because this is a y, let's call this y prime. And again, now it's just a matter of using the formula. So the formula says you're going to start with g, which is x squared plus 4 to the 1/3. You're going to multiply it times the derivative of f, which is just 1. Then the quotient rule is always a subtraction. Then you're going to multiply it times x, which is the numerator. And then you're going to multiply it times the derivative of g, which is 2x over 3 times x squared plus 4 to the negative 2/3 power. And remember, this is all over the denominator squared. So x squared plus 4 to the 1/3 squared. So take a minute to look at it, see if it makes sense. That's the calculus part. Now it's all a matter of doing the algebra. So to do the algebra, I'm just going to do the numerator first. So let's just look at the top of the fraction. Okay. If I'm looking at the top of the fraction, I'm going to go ahead and just try to rewrite it a little bit. The first thing that I notice here is that this is over 3 and this is just a 1. My life is going to be much, much easier if they're both over 3. So how can I change this 1 over 1 to be something over 3? So I'm going to write this as 3/3 x squared plus 4 to the 1/3 minus 2/3 x squared plus 4 to the negative 2/3. And again, just to be clear, this is just the top. I'm going to leave the bottom out for a second so I don't have to keep writing it. And now I need to factor. So I need to factor again between terms. Terms are separated by pluses and minuses. You're going to go ahead and take the GCF out of both. So if I'm trying to take the GCF out of both, okay, if I have a 3/3 and I have a 2/3, all I can take out is 1/3 because I can't take out 3 or 2, but I can take out 1/3 because I can't take out a 2 from a 3. Okay, then look at the x squared plus 4s. One of them is to the positive 1/3. One of them is to the negative 2/3. If one is positive and one is negative, which one should you take out? The negative. So again, that's my GCF. So now you're just trying to figure out what are you left with. So 3/3, if you take out 1/3, you're left with just a 3. Then how many x squared plus 4s are you left with to figure out? You do the original exponent minus what you took out. So that's 1/3 minus negative 2/3. Minus a minus becomes a plus. What's 1/3 plus 2/3? Again, not just the number one, but one copy. And again, yes, that happens most of the time, but you don't want to cheat. You want to be sure. You're doing 1/3 minus negative 2/3, which is 1/3 plus 2/3, which is 3/3. 1. So 1/3 minus negative 2/3 is 1/3 plus 2/3, which is 3/3, which is 1. That's okay. Again, that's just the first one. Now minus, you took out a 1/3, so you're left with a 2x squared. And you took out all of the x squared plus 4s, so that's all that you're left with. And again, just to be clear, this is still just the top. Almost done, but questions? Okay, so y prime equals 1/3 x squared plus 4 to the negative 2/3. That was my GCF. Now I'm going to distribute inside this parentheses. So this is 3x squared plus 12 minus 2x squared. If you combine those, what are you left with? X squared plus 12. And remember, this is all over the denominator squared. The denominator squared was over here. What happens if you have an exponent raised to another exponent? What do I do with them? Add, subtract, multiply, or divide? Multiply. So what's 1/3 times 2/3? Or 1/3 times 2 is 2/3. So again, I put my denominator squared back in. And then I'm done. I just have to do one last step to clean things up. Okay. So the first thing I'm going to do is I'm going to take this 1/3 and I'm just going to leave the 1 on the top and put the 3 on the bottom. The x squared plus 12, he's going to stay right where he is. And then tell me how I get rid of this negative exponent. You move it to the bottom. When you move it to the bottom, it becomes x squared plus 4 to the 2/3 on the bottom. Tell me something about both of these bottoms. They're the same. So how many x squared plus 4s do I really have on the bottom? 2/3 plus 2/3 is 4/3. So that is my final answer. X squared plus 12 on the top, 3 times x squared plus 4 to the 4/3 on the bottom. And again, I know that's not easy. Perhaps it's not really even that much fun. I did set up the lesson so it's getting easier as we go, not harder. So you're actually through the worst of them. Anything that's product or quotient is the biggest pain in the butt, but I'm pretty sure I only gave you one of each on the homework. And of course, I would only give you one of each, if that, on the quiz. So again, you just have to take your time and be methodical. So I would strongly encourage you to, again, catch up on the homework tonight if you need to. Okay, questions? Definitely the hardest lesson of the year that's left. So tomorrow or Wednesday is very, very short and quick and easy. So this is the hardest one for sure. Okay, number 3. Taking a look at this problem, okay, if I was to ask you for the big picture, meaning what at its core, what kind of a problem is this? Meaning, what kind of a derivative am I going to have to do first? What would you say? Well, you're going to have to use the quotient rule, but not yet, because the quotient is being raised to the 7th power. Because this is being raised to the 7th power, this is actually a power rule problem. And then, of course, a chain rule. And when you do the chain rule, it's actually going to wind up being a quotient. Also, just to be clear, you don't have to write this. I just think it's helpful to have a game plan. Know what it is you're supposed to do. Do the power rule, take the derivative of the inside, which is the quotient rule, simplify. So here's how we approach this one. Let's call it y prime. If I'm telling you to use the power rule, that means take that 7, move it to the front, take the entire quantity to the 1 less power, and now you have to do the derivative of the inside. So when you do the derivative of the inside, that's the chain rule, but you have to do the quotient rule. So I'm going to leave that black part by itself, and I'm going to pop out the quotient rule. So if I'm going to pop out the quotient rule, I'm doing the quotient rule for the yellow. So what's f? 2x minus 1. What's the derivative of f? 2. What is g? 3x plus 5. And the derivative of g? 3. Let's do the quotient rule off to the side. So the quotient rule off to the side says you're going to do g times the derivative of f. And again, I have the quotient rule memorized because I do it so many times. Please look at your green sheet if you need to. So denominator times the derivative of the numerator minus the numerator, 2x minus 1, times the derivative of the denominator, which is 3, all over the denominator squared. Let's just do the top. So if I'm just going to do the top, distribute the 2, 6x plus 10. Distribute the negative, gives you a negative 2x times 3, which is a negative 6x. Distribute the negative to the negative 1, becomes a positive 1, times 3 becomes a positive 3. Something pretty nice happens. The 6x's are done. So 13 over 3x plus 5 squared. So that was your little quotient rule interlude. To finish it up, you now have to put these two things together. So y prime equals 7. I'm going to take that 6th power, and I'm going to do the top to the 6th and the bottom to the 6th. I'm allowed to do that, and I think you're going to see in a minute why. Again, that was my original power rule. Take your quotient answer and put it right next to it. So times 13, 3x plus 5 squared. And for your final answer, 7 times 13 is 91. 2x minus 1 to the 6th. And then look at your bottom. They're all 3x plus 5s. If you add them up, how many are there all together? And that's it. I don't really know any better way to teach this to you guys other than you just have to take your time and be methodical about it. Okay, there's no shortcuts. The last two are the easier ones, so we'll finish up with those, but any questions to here? Please have your notes out when you go to do tonight's homework. And again, if you missed something, just rewatch today's video. Yes. I wanted to separate them, like instead of having the whole thing to the 6th, I wanted to separate them because I knew that I wanted to be able to combine the bottoms. Anybody else? Okay. So we saw one product, one quotient, one power rule, and now the last two. So just look at the last two side by side. They both have trig and they both have powers, but one of them is a trig problem and one of them is a power problem. So again, today is all about the big picture. So look at number 4. At its core, this is a cosine problem. Yes, there's an exponent, but the exponent is only for the 5x plus 1. So if I was going to ask what's the BP, big picture, this is a cosine problem, and then I'm going to have to use the chain rule. Again, one more time, you don't have to write this down, but I think it's good to have a game plan. And these are going to be much easier than the others because there's no factoring or anything crazy required. So y prime equals, using your green sheet or not, what's the derivative of the cosine of something, the negative sign of the same something. Then I have to use the chain rule, which means take the derivative of this. This is something being raised to a power, so I have to now use the power rule. So to take the derivative of the pink, I'm going to bring down the 4. Then I'm going to take the whole thing to the 1 less power, which is what? What's 1 less than 4? Then there's a new inside. I have to take the derivative again of this inside, which is 5. That's it as far as the calculus goes. Again, not that that's hard, but I need you to understand this is a cosine problem. Do the cosine first. That's the outside function. Do the power rule second. That's the middle function. Do the 5 last because that's the inside function. So all you're trying to do now is clean things up. Yes. Yes. Well, I'm just going to do it all together now. Like I'm going to clean it up right now. So for my final answer, y prime, I'm going to take this negative, this 4, and this 5, and just do a negative 20. I think that's kind of what you were asking, right? Like you can make it a negative 4. I just am going to wait and make it a negative 20.
I mean, we're right next to yellow.
Yep.
Wouldn't that be negative 4 sign?
Like, why wouldn't I just put it here?
No.
Like you need to take the derivative of this. So to take the derivative of this, you have to bring down the 4 and then do the whole thing to the 1 less power.
Okay. So when we bring down the 4, we're pretending there's like a 1 there, kind of?
Yeah.
Not the negative sign? Okay.
Right, yes. Okay, so I'm going to multiply negative times 4 times 5, which gives me negative 20. Then it really doesn't matter who you put next, so I'm going to do the sign of 5x plus 1 to the 4th, and then 5x plus 1 cubed. And yes, please don't do anything else to that. Again, if you look at that carefully, that is factored. I like that. I want things to be factored. Good question. You can't add them because this is the sign of something where this is just a regular. So you cannot combine them. So you can't combine because of the sign, just in case you want to write yourself a little note.
If we did it around the whole sign, plus 5x plus 1.
Sure. Okay, last problem then. Sine cubed of 4x squared. What you have to realize about this problem in order to do it correctly is that cubed, you must rewrite this as the sine of 4x squared, the whole thing cubed. If you don't rewrite it like that, you don't have a very good shot of getting the right answer. And then if I was to ask you for the big picture in this case is a power rule problem. And of course, the chain rule. Again, compare this to number 4. In number 4, you still had 3 functions, a power, a sine, and something else. You have the same 3 functions here, but they're in a different order. So because the whole thing is being cubed, when you go to start this problem, you have to do the cube first. So bring down the 3, take the entire quantity to the 1 less power, which is 2. Then do the chain rule for the first time. It's a sine. What's the derivative of the sine of something? The regular cosine of the same something. Then you have to do the chain rule one more time for this inside. And what's the derivative of 4x squared? 8x. Again, that's it as far as the calculus goes. All you have to do now to finish it is just try to clean it up. So if I was going to try to clean it up, I would probably multiply 3 times 8x just to get 24x. And then again, after that, it really doesn't matter. Sine of 4x squared and cosine of 4x squared. That's it. It's really just a matter of making sure that you are doing it in the right order. So work from the outside in. So at the bottom of the page there's the homework. It's 6 problems. Again, I advise you to look at the big picture and, of course, do it on a separate sheet of paper.